Hello everyone, hope you are doing great. In this session, we will revise all the heart rate calculation problems. If you are revising for your exam, it will be really helpful. This is an ECG paper. I have just shown for a sample. ECG paper, it shows small squares and large squares. We all know very well. So in each small square, thin horizontal and vertical lines will be present. These are the horizontal lines and these are the vertical lines. Yeah, a heavier thick line is present in every 5 millimeter. You can see a heavier thick line is present. So time is measured horizontally and voltage or height, or you can call it as amplitude, that is measured vertically. Time is in horizontal direction and amplitude is in vertical direction. Isoelectric line. What is an isoelectric line? It is the baseline in an ECG paper. In an ECG paper, if you see, there will be a baseline. So waves are measured either above positive deflection or below, that is negative deflection. If you can see a wave which is above, that is a positive deflection, and if the wave is below the isoelectric line, that is a negative deflection. Small squares and large squares, let us see more in detail about that. So here we saw, right, horizontal and vertical lines in an ECG paper are present. So let us just zoom out one part. In this, if we zoom out, we can see a very big, large box, right? So there are totally there are 25 boxes inside one big square. There are 25 small squares inside one big square. So first let us take one small square and let us see about that. If we take one small square, the height is 1 millimeter. The height is 1 millimeter and the time, that is 0.04 seconds. If we see the voltage, it is of 0.1 millivolt. This is for one small box. The same if we calculate for one big square. Then for 1 second in one small box, it is 0.04 seconds. Then in a large box, so 0.04 into how many small boxes are there here? 1, 2, 3, 4, 5. 0.04 into 5, if we multiply, we get 0.20. So 5 small squares are 0.20 seconds. The same applies here. For one small box, the height is 1 millimeter. For 5 small boxes, the height is 5 millimeter, 1 multiplied by 5. Now, if we see for millivolts, the same. 0.1 into 5, that is 0.5 MV. So these are the values for small and large squares, which we must remember before going into heart rate calculations. Coming to the standardization of ECG, normally 1 millivolt current is 10 millimeter in height, that is 10 small squares. If we see half strength, it is 5 millimeter, double strength, 5 fours are 20. Okay, recording speed is 25 millimeter per second. That is the normal speed in most of the ECG papers, but it varies accordingly in certain situations. See the formula for heart rate. Just see this once, 60-second method, 10-second method, and for large squares and for small squares. We will see about this deeply in next slides. Coming to a 60-second strip. For a 60-second method, what we have to do, we need to count the number of R waves and then multiply into 10. For example, this was a previous year question. There are 7 R waves in 60-second strip. Calculate the heart rate. So 60-second method, right? They have given 60-second strip in the question itself. You need to count the number of R waves. How many they have given? 7. So 7 multiplied by 10 is 70. So 70 beats per minute is the heart rate. The same, another question. There are 5 R waves. This is asked in August 2018. There are 5 R waves in a 60-second strip. So you need to count the number of R waves. See, they have given 5. 5 into 10, that is 50. Now coming to large square method. If you want to find the heart rate, 300 divided by number of large squares. So see here, if there are 3 large squares, in formula they have given 3 large squares. In formula, they have given 3 large squares and 300 divided by 3 is 100. Simple. Another one example, 4 large squares they are given in RR interval. So 300 divided by 4 is 750 beats per minute. Now, in a question, they have asked for large squares as well as small squares, which any one you can find out. Like that one question is given. And let us see that. The distance between two R waves. Okay, there are 3 big squares or 15 small squares. The speed is normal, that is 25 mm per second. 1 millimeter is equal to 1 small square. Everything is given. So just see one thing, number of large squares. How many large squares are there? 3. And the number of small squares, how many? 15. One you can find large squares or you can do small squares. That only they have asked. I have did for both 300 divided by 3 and 1500 divided by 15. Both comes the same answer. This was asked in April 2022. Now, the paper speed till now for all these problems we saw for 25 mm per second. Hereafter we will see for 50 mm per second. So this is the format. Like you can remember this like a formula. RR distance divided by paper speed is equal to duration of RR interval. Now, what you have to do, 60 seconds divided by the same duration of RR interval, we will get the heart rate. Let us see, okay? Calculate the heart rate, paper speed they have given, the distance between two peaks of QRS complex, that also they have given 20 mm. Now we have to find out the heart rate. What is the RR distance? They have given, right? The distance between two peaks of QR interval, that QRS complex, that is 20. So 20 divided by what is the paper speed they have given? 50. 20 divided by 50, you get it 0.4. Now in formula what they have said, 60 divided by 0.4, that is 150. This is the easiest method, method 1, which I always follow. There is another one method that is a long method. You just know it for once, right? Method 2 is for a normal speed, that is 25 mm per second, normal paper speed, one large box is 0.2 second, that is 200 ms, and one small box is 0.04 seconds, that is 40 ms. When the speed increases, what happens? The timing decreases. When speed increases, the time decreases. So in normal, we saw one large box is 0.2 second. The distance covered. Here, one large box is 0.1 second. So that is decreased. One small box also same. The value is being halved compared to 25 mm and 50 mm. Compared to 25 mm and 50 mm. So distance between two QRS complex, that is 20 mm, they have given in question. 20 millimeter in the sense 20 small boxes, because 1 millimeter is one small square, then 20 millimeter is 20 small squares. For 50 mm, one small box, we already saw, that is 0.02 seconds here, that value, okay? Then for we need to find out for 20 small boxes. So the value of 1 second multiplied by how many boxes? We get the timing, that is 0.4 seconds. 0.4 seconds in the sense there are 4 large boxes. Here we saw, right, 20 mm, 20 small boxes. This is the distance between the QRS and another QRS, that is the RR interval. I have tried to show here. The formula is 300 divided by number of large boxes between RR interval into 2. Or you can put 1500 divided by number of small boxes. How many? 20. 1500 divided by 20 into 2, if you put, you will get 150. If you put like this also, you will get 150. Hope you understand this. Let us go to our next example. Same 50 mm paper speed, QRS complex, the distance between two peaks is 12.5 mm. Find the heart rate. Apply everything in the formula. 12.5 divided by paper speed is 50, 0.25. Now 60 divided by 0.25 is 240. The second method, heart rate we have to calculate. Normal speed, you know very well, that value, one large box is equal to 0.2, one small box is 0.04. And for 50 mm, one large box is 0.1 and one small box is 0.02. So here the distance between the QRS complex in question, they have given 12 mm, 12.5 mm in the sense 12.5 small boxes. So for one small box in 50 mm per second, it is 0.02. So 0.02 into 12.5, you get 0.25. These are the small boxes here. So 1500 divided by 12.5 and multiply it into 2. You will get 240. The same. This is also the same question. You need to apply the value. Here they have given RR distance is 12 mm. Divided by paper speed, how much? 50 mm. So 12 divided by 50 is equal to 0.24. 60 divided by 0.24 is equal to 250. You try it in method 2. Just pause the video, try it in method 2. Afterwards, check the answer. Everything is same. Here the distance is 12 mm, that is 12 small boxes. For one small box, it is 0.02 seconds. So 0.02 into for 12 small boxes, that is 0.24 seconds. Now, what they have did, 1500 divided by how many small boxes? Divided by 12 into 2. You get the same 250. Hope you all enjoyed this session. Thanks for watching and stay tuned for our latest updates.